Good morning, good afternoon, and good evening, everyone, depending on where you are. Hello, I'm Jongwoong Kim and working as a swine nutritionist for Easy Family or Easy Group. First of all, thank you for the opportunity to join the 2022 New Agri-Food Research Institute of Jungang University. And today, I'll be talking about establishing optimum gut health in weaned pigs. This is the content of today's presentation. First, I'll be talking about general introduction of gut health and weaning process of piglet. Then, nutritional strategies to optimize gut health of piglet, including low crude protein, in short, CP diet, and dietary fiber, and some feed additives I strongly believe effective and efficient. And finally, I will conclude presentation with take-home message. Okay, let's get started. What is gut? As you all may know, gut is a metabolic organ. Nutrients from food or feed are digested, absorbed, and excreted. And furthermore, most of immune response is occurred in the gut because more than 70% of immune cells are present in the gut. It is only 5 to 7% of body mass. However, the gut accounts for 20 to 35% of whole body energy expenditure, and 20 to 60% of dietary amino acid are utilized in the gut, depending on the growth stage and health condition. And 100% of dietary glutamate are utilized in the gut as an energy source for intestinal epithelial cells. If we see this percentage herein, we can recognize how important maintaining gut health is. Then what is gut health? I guess we've been hearing the term gut health more than 1,000 times. However, gut health is a term that lacks a clear and concise definition despite its repeated using both animals and human health, medicine, and nutrition. I think the best definition is by Bishop 2011 in Gut Health, a new objective in medicine. According to the author, the gut health is defined as effective digestion and absorption of feed, and absence of gastrointestinal tract illness, and normal and stable microbiome of the gastrointestinal tract, and effective immune status and status of animal well-being. Then what affects gut health? The nutritional status has huge impact on immune function of body. Also, what we are or what pigs are eating also affect microbial population in the gut. On the contrary, immune function influences the nutritional status and microbial population in the gut, and microbiome affect nutritional status and immune function. In other words, nutrition, immune function, and microbiome must stay in homeostasis, and all factors are related to each other. Additionally, environment, like where the pigs are raised, and genotype of pigs, and how we manage pigs, and behavior or welfare status affect gut health as well. Moving on the topic, weaning process of piglet. I would say the weaning is the most stressful moment during pig's life. It imposes multiple and simultaneous stressors on young pigs. Before weaning or during the farrowing, piglets are fed sow's milk, which is in a liquid form. However, right after weaning, they feed what they are eating. is physically totally different from sow's milk. Nutritionally, solid type of feed are high in indigestible carbohydrates, lower in lipid, and amino acid profile are totally different from what they are used to eat. Also, after weaning, pigs are often mixed with different litters and moved to new rooms due to the structure of swine industry. Piglets have to be separated from the sow. The temperatures, locations of feeders and water supplier are different from where they are. And pigs are exposed to new pathogens, which may induce immune system stimulation to protect themselves. Because of these multiple and simultaneous stressors, piglets are typically suffered from weaning due to the impaired gut health. Okay, let's take a look at the post-weaning change within gut of pigs. The stomach have various functions in terms of initiation of protein digestion and modulation of microbial population in the gut. Exposure to low pH values is bactericidal for many pathogenic bacteria such as E. coli and Salmonella. In addition to its influence on nutrient digestion, maintenance of a low gastric pH value or lowering gastric pH value is essential for a healthy gut because this can help to reduce the passage of pathogenic bacteria into the small intestine. Compared with growing finishing pigs or the habit pigs, weaned pigs have higher gastric pH value due to a lower acid secretion capacity of the stomach. Because of the high gastric pH and reduced gastric motility that is usually observed post-weaning period, the gastric stasis may contribute to development of the post-weaning diarrhea, in short PWD, in piglets by allowing proliferation of pathogenic bacteria. In addition to the stomach, small intestine is also dramatically changed. The small intestine is a major site for nutrient digestion and absorption. However, after weaning, mainly due to the reduced feed intake, weaning pigs experience transient villus atrophy and crypt hyperplasia, resulting in decreased absorptive and secretive functions, a reduction in activities of pancreatic and enterocyte enzymes, as you can see in this figure. These changes are highly correlated with growth retardation and enteric disorders such as osmosis diarrhea. This figure shows the transepithelial electrical resistance, in short TER, and monitor flux in unweaned and weaned pigs. TER indicates resistance to transcellular permeability, and monitor flux indicates paracellular permeability. So high TER represent intact epithelial barrier, and low TER represent more permeable epithelial barrier. High flux rate indicate more permeable epithelial barrier, and low flux rate indicates intact epithelial barrier. As we can see in this figure, weaned pigs have significantly lower TER and higher monitor flux compared to the unweaned pigs, which tell us that gut health of weaned pigs is significantly compromised. Along with the physiologically changes in the gut, intestinal microbiome of pigs are also tremendously changed. Before farrowing in the uterus, the gastrointestinal tract in short GIT, of baby pigs is total. This is mainly due to the fact that they have no chance to be exposed to any bacteria. However, right after they are farrowed during lactation period, the small intestine of suckling piglet are dominated by lactobacillus and streptococcus, and large intestine by anaerobic gram-positive bacteria. This is probably due to the dietary source lactose in sow's milk. After weaning, when they start eating compound feed rather than sow's milk, the population of coliform bacteria increases in small intestine and gram-negative bacteria in large intestine. As you can see in this figure, the population of Enterobacteriaceae, so-called pathogenic bacteria, increase and take some time to decrease after weaning. And the population of lactobacillus, the one of the most well-known, the so-called beneficial bacteria, drops significantly right after weaning and increase in a short time. The important thing is gut microbiome takes some time to be 100% balanced and functional. The lovely microbiome in small intestine takes 7 days, and large intestinal microbiome takes more than 20 days to be balanced and functional. Okay, for the next, I'd like to combine gut health and weaning together. As I mentioned earlier, gut health of weaned pigs is significantly impaired. Therefore, many dietary interventions have been applied in piglet diet to try ameliorate the negative impact of weaning or improve gut health of piglet. As the most powerful and the efficient ways to improve and maintain gut health of weaned pigs, antibiotics has been therapeutically used to treat clinically diseased animal or prophylactically used to prevent and control common disease events. Furthermore, subtherapeutic use of antibiotics, so-called antibiotic growth promoters, in short AGP, has been widely used to improve weight gain and feed efficiency of pigs. However, due to the concerns against antibiotic resistance bacteria and antibiotic residue in pork, the use of AGP has been banned in many countries, including EU and some Asian countries. Let's take a look at Denmark case as an example. Until 1998, AGP had been used in the swine industry, especially in piglet diet. And age at 30 kilograms and mortality at that time were about 82.8 days and 2.8% respectively. As soon as Denmark pork industry stopped using AGP in the swine diet, the productivity parameters such as age at 30 kilograms and mortality increased by 2.8 days and 0.7% respectively. Yes, AGPs are powerful in terms of promoting growth performance of pigs. However, we all know that there are many problems of using antibiotics. So nutritionists around the world are still trying to develop and find alternatives to AGPs. As a second option, or as an alternative to AGP, the pharmacological level, which is much higher than requirement of zinc and copper, has been used in piglet diet. Addition of zinc as zinc oxide with 1,500 to 3,000 ppm and copper as copper sulfate with 100 to 250 ppm in piglet diet has been reported to have bactericidal effect, thereby controlling pathogenic bacteria and increasing growth performance as indicated in the figure. However, due to the environmental issues such as accumulation of heavy metals in topsoils and concerns against antibiotic resistance pathogenic bacteria, the use of high levels of zinc oxide as an alternative to AGP is also banned in EU this year, like AGPs. Indeed, according to one Canadian researcher, the prevalence of MRSA in manure was significantly higher when pigs were fed a diet containing 3,000 ppm of zinc oxide compared to those fed diet containing 100 ppm of zinc oxide. The most common, however, the most uncontrollable disease, post-weaning diarrhea, affect overall performance of pigs. This is mainly due to impaired gut health in weaned pigs. Negative impact of weaning will most likely increase with any dietary restriction of the use of subtherapeutic antibiotics and mineral compounds such as zinc oxide and copper sulfate. Therefore, we always need to find the best option to optimize gut health without AGP and zinc oxide. From now on, I will talk about the nutritional strategies to optimize gut health. The first topic is low crude protein diet. Of course, the protein and amino acid are important for growth and maintaining normal immune function. However, indigested protein passing to large intestine may have negative effect on gut health. Indigested protein are eventually fermented by bacteria in large intestine with decarboxylation and deamination and elimination process. And during this metabolic pathway, some harmful metabolites such as monoamine and polyamines, and ammonia, hydrogen sulfide, and some phenols and indoles are produced and induce changes in receptor ligand and cell proliferation, cytotoxicity, and buffering capacity. This may result in tight junction failure and reduced barrier function, thereby causing inflammation and translocation of pathogens in the gut. Therefore, managing dietary protein supply is one of the most important key factors for optimizing gut health. For the purpose of optimizing gut health, the fermentable protein or the indigestible protein supply should be minimized to reduce pathogenic microbial population and toxic metabolite in the gut. This also reduces metabolic cost associated with ammonia detoxification, which means extra energy is available for growth of pigs. Use of low crude protein diet with crystalline amino acid supplementation could be a good option to avoid unnecessary protein supply. Indeed, the pathogenic bacteria count were lower in piglet fed the low crude protein diet. Figure on the left shows the hierarchical composition of Clostridium family in the ileum of pigs before and after ETEC, the enterotoxin E.Coli challenge, and the E.Coli count of ileum and column on the right figure. Before and after ETEC challenge, the pigs fed low crude protein diet had lower hierarchical composition of Clostridium family, and also pigs fed 13% of crude protein had lower E. coli population compared to those fed 21% of crude protein diet. Also, the mucosa-associated ETEC was detected in 80% of pigs fed high protein diet. However, it was only 20% in pigs fed low protein diet. Furthermore, low protein diet reduced ETEC colonization in the small intestine about 40% compared high protein diet. Again, the dietary CP is an important factor mitigating ETEC addition and therefore ability to cause disease. Furthermore, as you can see in this figure, the ammonia, nitrogen, and cadaverine concentration increased as dietary protein increased, which may result from shift in microbial population. Increase in beneficial bacteria with decrease in harmful bacteria, producing less toxic metabolite, and therefore less incidence of diarrhea. If you see this regression data, the daily nitrogen intake or protein intake is highly correlated with incidence of post-weaning diarrhea, indicating less nitrogen intake led to less incidence of post-weaning diarrhea. This figure shows the villi height crypt depth ratio in weaned pigs fed low crude protein diet, challenged with ETEC K88. The villi height to crypt depth ratio is a good indicator of gut health because this value represents how serious villus atrophy. High value is better than low value because it means higher villi height. The feeding a low crude protein diet minimized villi atrophy in ETEC K88 challenged piglet. For the summary of low crude protein diet for optimizing gut health in piglet, the high crude protein diet have negative effect on piglet performance and gut health mainly due to the undesirable fermentation in large intestine. The use of low crude protein diet with amino acid supplemented diet, which meet the amino acid requirement of weaned pigs, can reduce negative effect related to high crude protein diet in weaned pigs by minimizing undesirable protein fermentation and reducing production of toxic compound and increasing beneficial bacteria and decreasing pathogenic bacteria and diarrhea. The reducing crude protein by 2 to 4% from the NRC recommendation would have no negative effect on growth performance unless crystalline amino acid are supplemented in the piglet diet. So for the second nutrition strategy to optimize gut health, I'd like to talk about dietary fiber. Dietary fiber have many pros and cons. For the performance aspect, excessive dietary fiber may have negative impact on growth performance because high in dietary fiber makes feed bulky and thereby reducing feed intake. Furthermore, excessive dietary fiber addition decreases nutrient digestibility and energy efficiency because gut endogenous losses and visceral organ weight and heat production increase. However, in terms of gut health, the dietary fiber is extremely beneficial to pigs. Due to the probiotic effect, the dietary fiber increase lactobacillus population and decrease E. coli and coliform bacteria. Furthermore, the dietary fiber increase short-chain fatty acid production, which can be used as energy source for gut epithelial cells, and decrease crude protein fermentation in large intestine, as discussed earlier. I will not show you the published data regarding how beneficial dietary fiber is, because we all know that dietary fiber is good for gut health. However, I'd like to introduce a kind of new concept, anti-diarrheal effect of insoluble fiber. The insoluble fiber addition increase visceral organ development and intestinal transit time. As a result, the non-digested materials and E. coli proliferation is reduced. These lead to reduction in protein fermentation in large intestine and E. coli addition in small intestine. All these mechanisms have positive effect on gut health and diarrhea. This figure shows the E.Coli K88 number in ileum mucosa of pigs challenged with E.Coli K88. Compared to the control pigs, pigs fed coarsely ground wheat bran had less E.Coli K88 in ileum mucosa and reduced diarrhea incidence. It seems like the particle size of wheat bran is important because it is related to the intestinal transit time. This positive effect of wheat bran supplementation is due to its washing out effect. ETEC K88 is not pathogenic bacteria before it attaches to glycoprotein receptor on epithelial cells of small intestine and release toxin into the bloodstream. By providing receptor analogs similar to glycoprotein of epithelial cells by the addition of wheat bran, E.Coli K88 attaches to wheat bran, not to intestine, and washed out before release toxin. Okay, let's move on to feed additives. The mode of action of most feed additives is controlling microbiome in the gut, such as reducing pathogenic bacteria and increasing beneficial bacteria, and thereby reducing gut damage and immune stimulation and diarrhea incidence. Due to the benefits on the gut health, more nutrients are available for growth and digestive and absorptive capacity is improved. So we can expect improved performance and gut health outcomes. As you can see in this list here, there are so many feed additives with potential to promote gut health and function, like organic acid, probiotics, prebiotics, and mineral compound and plasma protein, etc. As time is limited, among them, I'd like to talk about these 5 feed additives which have been reported to be effective in piglet diet, and the mode of action is well proved. The first feed additive is probiotics. The 3 main mode of action of probiotics are antimicrobial activity, enhancement of barrier function, and immunomodulation. The supplementation of probiotics decrease luminal pH, secrete antimicrobial peptide, and inhibit bacterial invasion, and block bacteria adhesion to epithelial cells. Therefore, antimicrobial activity increases. By increasing mucose production and enhancing barrier integrity, the barrier function of the gut is enhanced, and it has immunomodulation effect on epithelial and dendritic cells, and monocyte, macrophage, and lymphocyte. We can see the clear positive effect of probiotics in pigs challenged with ETEC K88 compared to the control pigs. The probiotic inhibit the growth of pathogenic E.Coli K88. The probiotic supplementation tended to support better growth performance and significantly reduced E.Coli K88 colonization on mucosal surface and diarrhea. The next feed additive is prebiotics. It is resistant to digestion in the upper gastrointestinal tract. Resistant to acid and enzymatic hydrolysis. So it can be used as a selective substrate for the growth of beneficial bacteria in the gut, thereby inducing luminal or systemic effects that are beneficial to host health. So it is called food for good bacteria. In this figure, the PC diet contains antibiotics, and 7-RS and 14-RS contains 7% and 14% of resistant starch in the NC, the negative control diet. The supplementation of resistant starch in piglet diet at 7% reduced diarrhea to the same level as on antibiotics, and furthermore, the resistant starch increases lactobacilli and bifidobacterium in the colon. 14% resistant starch reduces microbial richness and diversity in the colon, which is associated with digestive abnormality. There are a new term called symbiotics, providing probiotics and prebiotics together. Improve survival and implantation of live microbial dietary supplements. The different types of combinations, such as lactobacillus or bifidobacteria with inulin, fructooligosaccharides and galactooligosaccharides, etc., and colicin producing E. coli with low potato starch have been reported to be effective. The organic acid have acidification effect, thereby reducing intestinal pH and benefit the gut microflora with bacteriostatic effect on pathogenic bacteria. Dissociated protons from organic acid forms a pH barrier and disrupt colonization of pathogenic bacteria indirectly, and undissociated organic acid directly penetrate harmful bacteria and reduce its cytoplasmic pH, therefore killing the bacteria. The acidification lowered the stomach pH in weaned pigs, therefore protein and amino acid digestibility are improved. The stomach pH of weaned pigs is about 4.5. However, optimal pH of pepsinogen is at 1.8 to 3.5. For the digestion of protein, the pepsinogen should be converted to pepsin. However, the stomach pH of weaned pig is not low enough to activate pepsin. Therefore, the activation effect, the acidification effect of organic acid could improve protein digestion. Let's take a look at one nice review paper regarding organic acid. Due to the addition of organic acid to the diet, there were clear pH drop in diet and stomach. This reduction in pH increased the protein digestibility, as we can see here, and also the most of amino acid digestibility. Furthermore, the decrease in dietary pH may have positive effect on microbial population. The pig's fat diet containing organic acid have less E. coli and greater lactobacillus population in the gastrointestinal tract compared to the control group. Due to the acidification effect and the antimicrobial effect, the growth performance of weaned pigs fat diet containing organic acid have been improved. So the organic acid could be a good option for alternative to AGP. Bacteriophage is a virus that infect and replicate within the bacterium. The name bacteriophage comes from bacterio, means bacteria, and phage, eat. So bacteriophage means bacteria eater. The phage are widely distributed in locations populated by bacterial hosts, such as soil or the intestine of animals. The bacteriophage are the most common and diverse entities in the biospheres. It's about 10 to the 30 particles. Bacteriophage products are safe due to the host specificity and the unique life cycle. It works very specifically. So E. coli phage only works on E. coli, and Salmonella phage only attacks Salmonella. Therefore, it could be a good option for controlling target bacteria. Supplementation of dietary bacteriophage positively changed ileal microbial population and intestinal morphology in weaned pigs. The figure on the left and the right represent microbial population in ileum and small intestinal morphology respectively. The addition of bacteriophage cocktails contained Salmonella and Staphylococcus aureus and E. coli and Clostridium perfringens significantly reduced coliform bacteria and Clostridium and increased lactobacillus. Villus height increase may be due to the modulation of microbial population. Therefore, the bacteriophage would be a good option for controlling undesirable pathogenic bacteria. The last feed additives I'd like to talk about is nucleotide. They are building blocks of nucleic acid like RNA and DNA, and the building block of ATP and coenzymes. Nucleotides are involved in cell division and protein, lipid, and carbohydrate synthesis. Therefore, direct nucleotide addition to the diet may enhance the structural growth, especially the maturation of the immune system and gut mucosa. This figure shows the effect of dietary nucleotide on gut morphology in LPS, lipopolysaccharide challenged piglet. The nucleotide supplementation improved duodenum and jejunum villus height compared to the pigs challenged with LPS, and the efficacy was same as AGP. Furthermore, the nucleotide supplementation downregulated TNF-alpha and interleukin-10 in pigs challenged with LPS. Therefore, dietary nucleotide supplementation may be an efficient feed additive to enhance gut health of piglet. Finally, I will conclude this presentation with take-home message. Nutrition, immune status, and microbiome affect gut health and should stay in homeostasis. Weaning process have negative impact on gut health of piglet, and nutritional strategies to optimize gut health of piglet is important without the use of AGPs and mineral compounds such as zinc oxide and copper sulfate. A low crude protein diet and dietary fiber and some feed additives such as probiotics and prebiotics and organic acid and bacteriophage and nucleotide could be a good option. Okay, so this is all I have for this seminar regarding establishing optimum gut health in weaned pigs. Thanks for your attention for a long time in this presentation. And if you have any question, feel free to ask me anytime through this email. Thank you.